All right, so gait. So first things first, what is gait? So gait is essentially used synonymously with walking or running. So it's getting from point A to point B under your own power. So we use that to refer to walking or running, like I said. So all of this is going to be geared toward, or I'm going to be discussing walking. Running gait is pretty similar, and I'll mention the primary differences as we go along. So as mentioned, this is the first time I've done a gait lecture in this class, and a lot of this stuff admittedly is fairly advanced. Part of the reason I'm trying to do it is to show you the application of some of the stuff we talked about with the lower body. Actually, in terms of gait, the upper body is fairly important, especially trunk rotation and then arm movement. But just to keep things a little bit more simple, I eliminated any of the upper body stuff. So we're just talking about the lower body. So part of the idea here is to show you the application of some of the stuff, especially with the lower leg. And then, like I said, to kind of prepare you for what's coming in biomechanics, which is PEPROF 302. I know Mike likes to talk about gait some, so at least this way you'll be somewhat familiar with the terminology. So, all right. So in terms of the gait cycle, so some of this stuff I've alluded to a little bit when we talked about the musculature of the lower leg, and we talked about the joints in the foot as well. I kind of mentioned some of the phases of the gait cycle. So in terms of the gait cycle, so it runs from heel strike to heel strike. And so normally when people in typical gait, when somebody makes contact with the ground, the first thing is going to be their heel. So they're going to be in very slight plantar flexion over the top of the foot, and then they're going to push off, swing their leg through, and then their heel is going to hit the ground again. And so that first part of the gait cycle where it's initiated when that foot hits the ground, and typically that's referred to as heel strike. Now, not everybody hits the ground with their heel first, of course. Sometimes people hit the ground with their, especially if they have some kind of a problem with their calf, something up on their tippy toes. And so if they have that issue, or an issue similar to that, then sometimes it's just referred to as initial contact rather than heel strike, because that individual has no true heel strike. But assuming normal gait, then the cycle runs from heel on the right side through the following heel strike on the right side. So that's what's referred to as a stride. So there's a couple different terms here. There's strides and steps. So stride just looks at one leg or the other. I'm always going to use the right leg just to keep things simple. So stride then refers to the time between heel contact on the right leg to the next time you get heel contact on the right leg. So it's right to right, as opposed to a step is right to left. So a single step is right heel contact to left heel contact. And so there's several different things that we can measure in terms of the gait cycle. So one of the things that we can look at is stride length. That's going to be a really important variable in gait. And so stride length refers to the distance between those two heel strikes. So between the right heel hitting the first and second times, that's their stride length. And that's pretty variable. That's going to be one of the things that we alter to change our walking speed or running speed. So as we speed up, there's really two things that we can affect to increase our gait speed. There's two variables there. The first one is stride length, and the second one is stride rate. So stride length is how far do you step out. Essentially, it's a measure of how hard you're pushing off. Then stride rate is how many steps per minute. So it's the frequency, or I'm mixing up the terms there. How many strides per minute. So how many cycles does that right leg go through in the course of a minute? That is your stride rate. So whenever we speed up, the first thing that we do is increase our stride length. So we actually step out a little bit farther. So we do that by pushing off harder. And then to speed up a little bit more, we can increase the number of strides we take. So increase our leg turnover. So that is stride rate. So you've probably, if you've worked on improving your speed in different sports, worked on addressing the different aspects of this. So if you do things like lift weights, so if you do squats, deadlifts, any of that lower body stuff, calf raises, hill raises, etc., all of that stuff is geared toward increasing your ability to increase your stride. Push off the ground harder because your lower body is stronger, then you can increase your stride length, and so you can run faster, you can walk faster. Stride rate is a little tougher to train. So typically we train stride rate to try to get somebody to turn over their stride faster. The two most common ways to do that are towing. I don't know if you've ever done towing, but usually the way that works is you have somebody in front of you, and there's like a bungee cord or something attached to them, and they take off running and they pull you, and you try not to fall on your face. The idea there, if somebody explained the theory to you, the idea there is your stride turnover, so how fast you can move your legs. And then the other way that's done is through down. So you can, again, not to fall on your face, you're going to have to turn your strides over faster, and so that hopefully then will teach you to increase your stride rate. So a couple things going on this graphic. So you can see the purple bar, the top bar, so that's the stride, so right to right, and then down here the light blue are your steps, so left step and then right step. All right, so each stride then has two phases. So there's a stance phase and a swing phase. The stance phase is when you are weight bearing. The weight is over the top of the foot and it's touching the ground. Now, not necessarily all of the foot's touching the ground, but at least part of it is. So that's the stance phase. And that takes up about 60% of the gait cycle. So the way the gait cycle is broken down, especially in the graphics that I'm going to use, so 0% is right at heel contact on the right leg, and then through 60%, so we'll go through all these different phases here in a second, but when that foot comes off the ground at the end of a phase called toe off, now the foot has left the ground, now we're into the other phase, which is swing phase, which is where the foot is not in contact with the ground. So in the swing phase, as you can see, the foot's in the air, and we're advancing forward, going into the next step, or the next stride. Sorry, next stride is more appropriate. So moving on to the next stride in that swing phase. So if the stance phase makes up more than 60, or makes up approximately 60% of the gait cycle, then surely there must be overlap between the right and the left legs. And in fact, there is. So when both feet are on the ground, that is your double limb support phase, or that is a phase of double limb support. So one of the things that you can see on here when we first start the stride, so at heel contact here, that we have actually a phase of double limb support. So the left leg is still on the ground here. And so we've got this period of overlap between the two. So where both the right leg and the left leg are on the ground, that's double limb support. And then the left leg is going to leave the ground. So then the left leg is going to move into a swing phase. And now, from about 10% of the gait cycle to about 50%, we're only on our right leg. So that's what's referred to as single limb support. So single limb support, you're only bearing weight on one side or the other, in this case, the right side. Then our left heel is going to hit the ground right here. And so again, you got that overlap between the right and left, so another period of double limb support. So at about 0% to 10% and 50% to 60% of the gait cycle, there's some overlap between when the right foot and the left foot are on the ground, and so those are periods of double limb support. Everything else in the gait cycle is single limb support. And the key differentiator between walking and running is that double limb support. So we didn't have the summer games this year, but if we had, you might have seen, have you ever seen race walking? It's pretty entertaining. Yeah, it's such a weird motion. It's like, it takes some real training to be able to do that. And so there's a lot of like knee hyperextension, there's a lot of hip motion there to enable them to do that. But in race walking, what will get them disqualified is if they start running. And so the differentiator that the judges are looking for between running and walking is that they have to have phases of double limb support. So if you switch to running, the differentiator there is there's a flight phase. So there's a period where neither of the feet are touching the ground. That's the flight phase. And so that's the difference between walking and running, is that flight phase. So, that's what I was going to say, is that, so for most of us, if you've ever like just stood on a treadmill and cranked it up, there's a period, so you start walking faster and faster. There's obviously a changeover point at which it's just more efficient and much more comfortable to switch from walking to running. For most people, that's around 4.8 to 5 miles an hour. They try to walk at 4.8 miles an hour, like that is moving. That's uncomfortable. So I feel like I usually switch over about 4.5. But anyway, so 4.8 to 5 is where most people switch over from walking to running. Maximum walking speed appears to be somewhere between 5.5 and 5.7 miles an hour. So the race walkers, that's about what they do. So it's a little bit slower than a 10-minute mile is typically what they achieve. If somebody, to decrease speed, we can either decrease the number of steps we take per minute, so decrease the frequency, or we can decrease our stride length. And so one of the things that you see in the elderly is that they tend to obviously take shorter strides, so they don't step. They take fewer strides per minute. But one of the big differentiators between the elderly and people age and younger is stride length. And so the shorter steps you take and the slower the steps you take, the longer periods of double limb support you've got, so you got better balance. It's harder to fall over. Out we step, now we have longer periods of single limb support, and so it's easier to fall over. So the adjustments people make if they're unstable, they take shorter strides and they take fewer strides per minute to try to maximize that double limb support time so they don't fall over. All right, so in the stance phase, there's 5 events in that. As mentioned, the first event is heel contact or heel strike. So when your heel first hits the ground, that initiates that particular stride. And so what we're going to do, your heel's going to hit the ground in slight plantar flexion, and it's going to move into a little bit until your forefoot hits the ground. And so we're moving from heel contact here at 0% to what's called foot flat at about 8 to 10% of the gait cycle. And so when that happens, the foot moves from slight plantar flexion to more plantar flexion. And so again, foot flat is where that forefoot makes contact with the ground. And so the entire plantar surface, the entire bottom surface of the foot is in contact with the ground there at flat foot. One of the important things to know about flat foot is that that transition from heel contact to flat foot is governed is probably not the right word, but stabilized is a better word by the dorsiflexors of the foot. So in particular, tibialis anterior, that's going to be a really important muscle. Remember that tibialis anterior is a dorsiflexor of the foot and an inverter. And so tibialis anterior is going to be eccentrically contracting, so contracting but lengthening and decelerating or slowing down contraction. The foot then hits the ground. So if you don't have good dorsiflexion strength, so again, particularly tibialis anterior, maybe somebody had an injury, maybe they had a stroke, something to that effect, what you get is they just can't put the brakes on. So the foot just, every time they hit the ground, it just smacks the ground. So that's a pretty common issue if you work in a PT clinic. There will be a lot of people that have foot slap and then the inability to pick up the foot during the swing phase. I'll show you what that looks like. So that's foot flat, and then we move from foot flat to mid stance. So now we are moving from where the foot's flat with the ground to mid stance here. And so basically what you're doing then is moving from your center of mass, the center of mass is behind the foot to where it's directly over the top of the foot. And so that is the movement that occurs from flat foot to mid stance. So you actually move from plantar flexion to neutral and then eventually dorsiflexion there in that stance leg. And then as we go to push ourselves into the next step, as we move from mid stance to the next phase, which is heel off. So as you go to push off, you're going to pick up that heel on that right leg. You're going to move into plantar flexion there. So heel comes off the ground. We're going to bring our center of mass farther in front of that foot, and we're going to hyperextend our big toe, so hallux at that metatarsophalangeal joint, and then push off with our big toe, and that's called toe off. So toe off is when you move from hyperextension of the first MTP joint until it actually comes off the ground. So that's the last event of the stance phase. And so from heel off to toe off here, you can see down here that phase is often called push off. So that's when you move. There's the combination from heel off to toe off. That's pushing you into the next step. So in gait, a lot of times textbooks talk about how gait is essentially this combination of loss of balance and regaining of balance. Because effectively what we do is we kind of lean forward a little bit, and then in order to not fall over, I put one leg in front of the other, and then I regain the balance over the top of that leg in mid-stance, and then I lean forward and fall into the next step. So it's this just continual process of losing balance and regaining balance. And so you can kind of see that here as we move from mid-stance to heel off. You know, you can see him kind of leaning forward a little bit. His center of mass or center of gravity is outside of his base of support, so then he has to bring his left leg forward to increase his base of support and keep from falling over. So those are the events of the stance phase. Swing phase is a little more nebulous. There's 3 parts of it. So early swing is right after toe off. So when your foot leaves the ground, that's your early swing phase. An early swing phase basically goes from the end of toe off until right before, again, sticking with the right leg as a reference point, right before the right leg passes the left, because then you transition to mid stance. So mid stance is kind of, again, fairly loosely defined, but it is basically the period just before the right leg passes the left and just after the right leg passes the left. So all of that is mid stance, and then we move into, mid swing. Then we move into the late swing phase, which is where you continue to flex the hip and then you start to extend the knee. So knee extension is going to be one of the big markers of the late swing phase. All right, so I mentioned center of mass. So it's this hypothetical point about which, so it's basically if you averaged all the body's mass, you average the mass of your right leg, your left leg, your trunk, your arms, where would that all be centered in the body? So in us, it's just a little bit below your belly button, so that's your umbilicus. Center of mass depends upon your makeup, so it's typically actually a little bit lower in women than it is in men. Men tend to have more upper body musculature, tend to have more weight up high, and so men tend to have a higher center of mass than women. But in general, it's just below your belly button. So our center of mass then moves up and down throughout the gait cycle, and then it also moves left and right throughout the gait cycle. So what you can see on this top picture here is that when we are in double limb support, so when both feet are on the ground, is about the lowest that your center of mass gets. So your center of mass drops a little bit there, and then as we move from that double limb support to mid stance, so single support right in the middle of the gait cycle with all of our weight over either the right or the left leg, then our center of mass moves up, and then as we move again into double limb support, it goes back down. So it kind of oscillates up and down. In most people, it moves up and down about 2 inches throughout the gait cycle. And then a similar kind of thing happens between left and right movement. So as we step over the top of our right leg, center of mass shifts right, comes close to the middle of the right foot, and then as we take a step with the left, center of mass then shifts to the left side. So it shifts left and right about 1.5 inches. So throughout the gait cycle then, goes up and down about 2 inches, moves about 1.5 inches left and right over the course of that cycle. With respect to walking and running, again, one of the differentiators there, when you run, the center of mass comes up even higher. One of the reasons that running's energy expenditure is a little bit higher than it is for walking is because you have to project that center of mass a little bit higher to go into that flight phase. So running does use a little bit more energy than walking does because of that, because you have to propel the center of mass a little bit higher. So that requires a push off. On the left and right oscillation there, reasons we do that, it's actually an energy saving move. So if we move the center of mass closer to my hip joint, take some pressure is not the right word, take some of the load off of the hip adductor, so glute medius, glute minimus, TFL on that right side, in that case the weight bearing side, so where all my weight is. By moving the center of mass closer to the hip, it takes some of the load off of those hip abductors. It's actually an energy saving move to shift our center of mass left and right as we take steps. All right, so 2 terms on there. You don't have to know them, but since they're on every slide, since every slide says kinematics, I thought I should define the terms for you. So you're going to see both these terms, certainly some, maybe a lot, in biomechanics. So there's kinetics and there's kinematics. So the difference between the two is that kinetics is a study of forces. So it's a study of things like muscle contraction or friction or lack of friction, what else? Inertia, those kinds of things. So it's a study of forces. And then kinematics is the study of the motion produced by those forces. So all these next slides, all we're doing is we're looking at motions. So we're looking at is the hip in flexion or extension, knee in flexion or extension, et cetera. So we're looking at the motions. We're not looking at the forces that cause those motions. So you don't have to know either of those terms, mostly an FYI, since it's, like I said, since it's at the top of every slide. All right, so what happens with the hip during gait? So when we first hit heel strike, the hip is in about 30 degrees of flexion. And then obviously we move from that flexion to where you go to foot flat, and then you end up in mid stance. So we're right over the top of that foot. So then the hip is in a neutral position. And then as we go to push off, the hip moves from flexion to extension. And so you can see that on this little diagram here. So when we hit the ground right there at heel strike, the hip is at about 30 degrees of flexion, and then the degrees of flexion drop. So we move closer into extension until we get to close to mid stance here. Right, so we're almost at 0 there, and then we're going to move to extension as we move into heel off, and then into toe off. Now we're going to move back into flexion. So what this reflects then is the swing phase. As the foot comes off the ground, the hip moves back into flexion there. So for normal gait, you need about 30 degrees of hip flexion and about 10 degrees of hip extension. And so most commonly people are lacking in the extension category. So if somebody can't extend the hip, what they can do is a variety of substitution motions. And so basically what substitution motion is if I can't get motion at the hip joint, I'll get it somewhere else to try to have a fairly normal gait. And so the most common ones in the hip are, if I can't push off, what I'm going to do is actually move my pelvis. So rather than moving at the acetabulo-femoral joint, I'll move the pelvis forwards or backwards. So we've talked before about two types of pelvic tilt. There are others, but we've talked mostly about two. So there's anterior pelvic tilt, which is to take the ASIS, rotate it toward the ground, so kind of that beer belly or pregnant lady posture. And so what that does is it hyperextends the low back. And so if somebody can't get enough hip extension, what they'll do is they'll anteriorly tilt their pelvis and they'll hyperextend the low back to get that motion. So if somebody has a lack of range of motion in the hip, particularly in hip extension, they'll still have a fairly normal looking gait, but they're not getting it at the hip joint. Instead, they're getting it actually from the low back. So one of the things to make life complicated is that whenever somebody has low back pain related to walking or running, one of the things we have to look at is their hip range of motion. We'll also talk about foot range of motion because, again, because of those substitution motions, the reason they're having back pain may not necessarily be because there's inherently a problem with the back. It may be that the back is getting motion to make up for lack of range of motion in the ankle and the knee or the hip, in this case the hip. All right, so that's the hip. So then on to the knee. So what does the knee do throughout the gait cycle? So as you can see there, it's at slight flexion and heel strike. And so that plays an important role in slowing us down, in absorbing the shock of gait. And you see the same thing whenever you're running as well. So sometimes people will report, after they go out and run when they haven't before, that their quads are sore. And one of the primary reasons their quads are sore is from that deceleration at heel strike, where the knee is going from slight flexion to actually a little bit more flexion. I don't remember if I have the degrees on here or not. I think it goes from like 5 degrees of flexion to about 15. And so when it does that, the quads, remember your quads are your primary knee extensor, so they are just like we talked about with the dorsiflexors, they're going to be contracting but lengthening. And so they're going to be engaged in an eccentric contraction, which hopefully you'll remember are the types of contractions that do more damage to the muscles, tend to cause more muscle soreness. So the quads then act as some of the primary shock absorbers at heel strike. They're going to contract and then lengthen a little bit to allow the knee to fall into a little bit more flexion. Again, we're moving from about 5 degrees of flexion to about 15, so it's not a ton, but they're going to slow the body down. Then we're going to move from that slight flexion to, we're going to actually kind of stand up over the top of that right leg, so then we're going to extend at the knee. So you move from that, give or take 15 degrees of flexion, to flat foot, to now we're extending the knee through mid stance, and then we really fully extend it at heel off, and then we actually start to flex it a little bit at heel off. And then you get flexion to toe off and through mid swing. So here's our knee here. So again, about, this little chart has a little bit more flexion. That's okay. So anyway, so you hit it about 5 degrees. This one has it going up to about 25 degrees of flexion. And then again, extension until about heel off. And then we're going to start to flex the knee again. And you can see this big flexion wave here. That's from the swing phase. You're actually going to flex the knee to carry your leg through. That's also an energy saving move. Because the more you can flex the leg as you're carrying it through on the swing phase, you got more mass closer to the axis of rotation, which the primary axis of rotation during the swing phase is the hip. And so that reduces the intensity of muscle or contraction that's required to move the leg into the next stride. So, and then extension into the late swing phase to prepare for the next stride so that we can hit the brakes again whenever we hit heel strike. All right, talocrural joint. Remember at the talocrural joint we get plantar flexion, dorsiflexion. Those are the primary two things that happen on there or at that joint. And so in terms of abbreviations on this slide, you're going to see PF, that's plantar flexion, DF is dorsiflexion. So at heel strike, in terms of plantar flexion, dorsiflexion, you're actually you're essentially neutral, and then you're going to move into plantar flexion. So we're going to move into about 10 degrees of plantar flexion whenever we hit foot flat. So you're going to be neutral at heel strike, drop into plantar flexion at foot flat, and then you're going to come up over the top of that. So then we move into a neutral position just before, so you actually are fairly neutral right in the middle of mid stance. And then as we move to break it down even more into late mid stance, so as you're getting ready to pick up your left leg, the right ankle is going to move into about 10 degrees of dorsiflexion. And then as we heel off, you're going to plantar flex. And then as you toe off, you get about 20 degrees of plantar flexion. So normal gait then, the numbers that matter or where they matter, you got to have about 10 degrees of dorsiflexion to get through mid stance, and then about 20 degrees of plantar flexion through the push off. So usually if people are lacking one or the other, they're lacking dorsiflexion. So maybe they've got really tight calves. If their calves are really tight, because again, those are plantar flexors, they're not going to let you dorsiflex. And so if somebody can't really come over the top of their foot, what they're going to do to try to get that range of motion, there's a couple different strategies they can take. One of them is that they'll rotate their hip out a little bit and then kind of roll off of their big toe. So it's a fairly common strategy. And so they may get it at the hip. They also may get it at the knee. So one of the things you'll see is they'll kind of internally rotate at the knee to try to get that range of motion as well. So lack of dorsiflexion is one of the big ones that causes substitution patterns. All right, and then the first MTP joint, so your big toe. So you can see there it's slightly extended whenever you make heel contact, neutral until we get the heel off, and then we get lots of range of motion. So when the heel comes off the ground until toe off, so you're really going to push your weight from actually kind of the lateral aspect of the foot back to the medial aspect of the foot, back across that big toe. We're going to hyperextend that big toe, so about 45, 55 degrees, and then we're really going to powerfully flex the big toe. So we're going to use flexor hallucis longus to help push us into the next step. It's a pretty important muscle for gait. And so then that helps push us into the next step. And so that, I mentioned before, the injury that is turf toe. And so turf toe is a hyperextension injury of the big toe. You, again, damage the capsule on the underside of the big toe or on the plantar aspect. And so what happens then is we can't get that normal 55 degrees of extension. It's going to hurt every time you hyperextend the big toe. And so in terms of substitution motions, then what we get is that rather than really getting a good toe extension during or right before toe off, what we're going to get is that people just kind of pick that leg up. So rather than pushing off, they're going to pull through. So they're really going to engage the hip flexors and the knee flexors to try to pull them through to the next step rather than pushing into the next step. All right, so all that was sagittal plane motion. So all that was flexion extension stuff, plantar flexion, dorsiflexion stuff. So I do have a few things. I kind of picked the highlights from the other planes. So one of the important things that happens during gait is a little bit of pelvic drop. Now, obviously, it can become excessive, and we've talked about excessive pelvic drop a little bit before. So some of the terminology on the slide, so drop on NWB. NWB stands for non-weight bearing. So it's the side that's in the swing phase in terms of the terminology that we've been using. So what happens is if you're in the stance phase, single limb support on the right side, on the left side, that leg is going to be in the swing phase. And so initially, you're going to get a drop of the pelvis on the non-weight bearing side. And so you're going to get an eccentric contraction of the hip abductors, so particularly glute medius and glute minimus. Those are the big two to know. So glute medius, glute minimus are going to contract eccentrically to decelerate us, to slow us down and limit that pelvic drop. And then as we move into the next step, so as we start to really bring our left leg forward and move into mid-swing and late swing, we're going to get a concentric contraction. So those muscles are going to concentrically contract to raise our pelvis back up. And so you can see that here. So you're going to get that initial pelvic drop just before mid-stance, so actually foot flat's right here. So actually just before foot flat. And then as we move that left leg forward, the left side of the pelvis is going to pop back up. I already mentioned this shift in the center of mass. All right, subtalar joint. So this one's important. Not that the hip ABA deduction wasn't. So subtalar joint, remember what I want you to know about that is that you get inversion, eversion of the calcaneus there at the subtalar joint. So remember that's the interaction of the talus and the calcaneus. Inversion, calcaneus rolls toward the midline or slides toward the midline. Eversion is that the calcaneus slides away from the midline. And so I mentioned this a little bit before. So the subtalar joint So that actually, I have to fix my slide. That should say inverted at heel contact, because you can see that here. So where it says everted here, that should be inverted. So I'll fix that and repost that. But anyway, so you're at slight inversion there at heel contact. So your calcaneus is inverted about 2 degrees at heel contact, and then it's going to really rapidly evert. So it's going to move laterally fairly rapidly. So it's going to slide those 2 degrees, and you can see there at mid-stance, it's everted about 2 degrees. And then, so what that does, why that matters. So I mentioned this before, when the calcaneus is in inversion, that's going to push all those tarsal bones together and into the metatarsals. That makes the foot nice and rigid. So we want the foot nice and rigid whenever we hit at heel strike. And then, once we've got that rigid heel strike, now the calcaneus is going to evert as we move into mid-stance. And so what that does then is it allows those bones to slide apart. And so it allows that some of the shock absorption, or some of the force whenever we hit the ground, to dissipate through some of the soft tissue of the foot. So it allows those forces to dissipate through the joint capsules in the foot, through the intrinsic muscles of the foot, etc. So that's an important force dampening mechanism by allowing that calcaneus to evert a little bit, again, spreading the foot out and dampening the force that then goes up the shin and into the quads. And then what we're going to do after mid-stance is we're actually going to rapidly invert the calcaneus again. And so you can see at about heel off, we're close to neutral, and then we're going to rapidly invert the calcaneus through toe off. And so what that does is that, again, changes the foot back through the push-off phase. So remember, push-off goes from heel off to toe off. So we want that foot to be nice and rigid to help push us into the next step. And what I want you to know is that the primary muscle that does that is tibialis posterior. So tibialis posterior is going to invert that, or play a role in raising that arch of the foot, the medial longitudinal arch, which plays a role in inversion at the subtalar joint. And so that helps lock the foot. So tibialis posterior is along with tibialis anterior in relocking the foot, again, sort of indirectly re-inverting that calcaneus so we can have a nice rigid lever. So you go from 2 degrees of inversion to about 2 degrees of eversion to eventually 6 degrees of inversion during push-off. And then as far as, so this is the last of the planes. So horizontal plane, we're going to get rotary motion. So you slight external rotation of the hip to internal rotation as we step over the top of the foot. And so that's, again, another sort of a shock absorption mechanism. So as we go from rotate internally, that again is going to help me dampen some of the forces. So that takes some of the load off of the quads as well, and it puts it on those external rotators of the hip. The deep six muscles we talked about, as well as muscles like sartorius, TFL, some of those other muscles are going to play roles in stabilization there. The other thing that does is as we internally rotate through mid-stance is it helps bring the left leg forward. So as we internally rotate the hip, that's going to then play a role in swinging the left leg forward during its swing phase. So it helps enhance the action of the hip flexors on the non-weight-bearing side. The internal rotation on the weight-bearing side helps augment that. All right, so in terms of specific muscles, so glute max, and I won't go through each of these on the little chart here, but you can see where they're active in each phase. So for example, glute max is pretty active there, heel strike through almost a flat foot, and then its activity goes back down until we get to the next heel strike. So what glute max does is it plays an important role in stabilizing the hip. So basically we want it to be good when the heel hits the ground so that we don't get unwanted hip flexion. So if glute max is weak or inactive, what we could get is too much trunk sway. So you actually might fall too far forward and have this uncontrolled flexion. So glute max helps prevent that. The hip flexors, so iliopsoas is actually fairly active at the end of, or as we move into heel off, and it's actually active eccentrically. So one of the things we haven't talked about a ton is the interaction between muscles, the interaction between agonists and antagonists, but we can start to see that here during the gait cycle. So as we move into hip extension at heel off, you're going to get some contraction of the hip flexors to limit that hip extension to basically stabilize the hip. Rectus femoris and sartorius are going to be active in that swing phase, so when we bring the leg through, and iliopsoas has some involvement in that as well. The AB ductors, so again, primarily glute medius and glute minimus, their job, again, is going to be to eccentrically contract whenever we are moving into mid-stance on that weight-bearing leg, and then to concentrically contract to help hike the hip, to lift the non-weight-bearing side of the pelvis to help us move into the next step. And then the adductors, primarily stabilizers. So the adductors, and you can see it on here, so for example, magnus longus down here, are going to be really active at heel strike, and they are primarily active as stabilizers. So they want to make sure the leg doesn't bow out, the leg doesn't rotate when we don't want it to, and so the adductors are really active during that initial heel strike as stabilizers. The other thing that they do is, particularly adductor magnus, those anterior fibers, and adductor longus are going to be hip flexors, so they're involved in the swing phase, so they help bring the leg through. The internal rotators, so particularly glute medius, the anterior fibers of it, and then are going to be active in internally rotating the hip a little bit on the weight to help facilitate that swing on the non-weight bearing side. And again, the external rotators, just like the adductors, are going to be really active at heel strike, and they're going to prevent that internal rotation or the tendency to rotate internally whenever the heel hits the ground. I mentioned the activity of the quads earlier. So again, the quads are active at a couple points. So they're active late in the swing phase because they're going to extend the knee almost fully, so lacking about 5 degrees of full extension. And then they're going to contract to decelerate the leg, or decelerate the body as the heel hits the ground and we move over the top of the leg. And as you can see there, rectus femoris also plays a role because it's the only one of the 4 that's a hip flexor. It plays a role in bringing us into the next step. The hamstrings, their important role, particularly for biceps femoris, is going to be at the end of that late swing phase. They're going to decelerate the knee into extension. So they're going to make sure we don't fully extend the knee. So again, particularly biceps femoris is going to play a role in that. So they decelerate extension in that late swing phase. And then after the heel hits the ground, pull through. So they're going to be active in their role as hip extensors to pull us over the top of the foot and propel us into the next step. And then as we move from toe off into the swing phase on the right side, the hamstrings are going to be active in flexing the knee. But actually, we don't really do that as actively with the hamstring. The primary flexors of the knee are going to be will be passive flexion. If we flex the hip, we'll just kind of relax a little bit, and that'll passively flex the knee. But gastrocnemius is also active in flexing the knee as well during that swing phase. So the hamstrings play some role, but most of it comes from passive flexion due to hip flexion, and then also from a little bit of activity from gastroc. So in the foot muscles, so I already mentioned the role of tibialis anterior. The thing I want you to know is that it's going to decelerate the foot, slow it down, back to foot flat, keep the foot from flat. And then tibialis anterior is also active during the swing phase. It's going to pick your foot up. So if tibialis anterior is not strong enough, then what we're going to get is called foot drop, or drop foot, the way I've got it listed there. And so when that happens, to keep the toes from dragging the ground, what we'll have to do is a sort of a compensatory motion where we'll either flex a lot more of the hip, or we'll get what's called hip hiking. So you really exaggerate that lateral tilt of the pelvis. You really, if my right leg's in the swing phase, really pick up that right ASIS to try to bring that leg through to compensate for that lack of dorsiflexion. And then the plantar flexors. So once you go from foot flat to mid stance, they're actually going to be contracting eccentrically. So you're going to slow down. Again, you don't fall too far forward. Then they move from that to concentric as we move from heel off into toe off to help push us into the next step. And as mentioned, gastroc is going to flex the knee. So again, tibialis posterior, the important thing I want you to know about it is that it's going to be really active during that push-off to re-invert the calcaneus to make the foot a nice rigid lever. So of the foot. So yeah, so I want you to know about it. And I think, okay, good. So now I got some videos of people with different sorts of gait alterations. So this first one, I'll just show you what it looks like. So watch his right leg, and this one tells you what he's doing. So you can see that sort of shuffling gait, but notice that his right toe keeps dragging the ground. And so what he's got is a weakness of tibialis anterior. And you can see there they accentuate that to make up for that, he's going to really hip hike. So he's really going to pick up the pelvis on that non-weight bearing side to try to compensate. Plus anterior issue. And so he's got his foot slapping the ground. So I'll show that one more time. So we're still doing the foot drag here. So you can see that foot slapping the ground as he hits because he's getting no eccentric contraction. Dorsiflexor weakness can present either way, either as that foot slap or as that sort of toe drag kind of a gait. For this one, you wouldn't ever see one that actually looks like this. Oops, let's back up one. So I'm not really sure what's wrong with his Achilles or with his gastroc complex, but what you can see here is that he has really limited dorsiflexion, right? So he's basically stuck in plantar flexion. And so in terms of the whole initial contact, so his initial contact is obviously in the forefoot. He doesn't have a heel strike because he's always stuck in plantar flexion. And so another couple things you can see here. So it's, oh, let me make this go away. So again, he's stuck in plantar flexion on this side, but you'll notice there's a pretty significant difference in the musculature in the lower leg on this side as opposed to this side. So what he's doing in terms of compensation motion, because he can't dorsiflex and he can't push off because he's stuck in plantar flexion, is he's getting a lot more contraction of the hip flexor. So he's really pulling that leg through. And so you can see that to some extent his right side is a little bit better developed on the thigh than the left side is. So that those compensation patterns then become a little bit more obvious through the size of the musculature. All right, this one's a classic gait issue. It's called the Trendelenburg gait. So there's actually a test called the Trendelenburg test. And so what the Trendelenburg test looks for is weakness of the hip abductors, particularly glute medius and minimus. And so what you do in the Trendelenburg test is you look at somebody from the back. You have to find their PSIS. Remember, those are the butt dimples. You say, okay, what I want you to do is stand with your weight even, and then just pick your right leg up off the ground. Well, I'm going to do left. So pick your leg up off the ground, and what you're looking for is how much their pelvis drops. And so if their pelvis drops quite a bit, if it's a noticeable drop, then you're going to assume they have weakness on that side, and so then that's what's leading to that sort of lurch gait. And so you're going to see this in this woman. So on her right side, she has pretty significant weakness of the abductors, so watch the lurch to the right. There. And so that's a Trendelenburg gait where the hip really rocks to one side or the other. We'll skip the cane. And then the last one I got for you is somebody who is really lacking in plantar flexion strength. And so, and probably dorsiflexion range of motion, probably a combination of the two. And so because of that, she's going to get that motion in terms of substitution pattern. She's going to get it from knee hyperextension. And you can already see it here, how hyperextended her knee is. And so obviously on her right side, so she can't push off at all with the left. So again, she's going to, or sorry, with the right. So she's going to push through, or pull through, sorry, on the right side. So you can get that hyperextended knee, no plantar flexion at all. And so she's using that knee hyperextension to compensate for the lack of dorsiflexion. So yeah, any questions or anything? Cool. All right, so then that's it for gait.